Got this. Thank you. So thank you, everybody, for being here today. The Python Education Summit is one of my favorite events of the year because it's the only place all year I get to be around a whole bunch of people who are just as passionate as me about education and Python. And that's a really special sort of nerd, I have to say. So thank you for making it what it is by being here. So today, we are going to be having a conversation together and working together on open education resources for Python. So I wanted to really dig into what makes those resources work. What do we need? How can we do this differently? How can we build on what we're doing? And because this is a Python conference, I have put all of this into a form, the Zen of Python, open education resources. Let me grab this. It works. All right, so if it's your thing, please tweet along. Part of the theme today is bringing together people in the technology sector and education sector. So I've put up hashtags that are popular in tech and in education. Maybe it doesn't work. There we go. So I want to start out by telling you about the best Python open education resource I've ever created. I used to work for a startup where I was writing middle school Python curriculum. We had a visual interface that was in the browser. Students could code in Python, and very much like Scratch, they would see an animation in the browser that they could program. So we really struggled between how do you show guide instruction and support students versus helping them build open and problem-solving skills. And we struggled with that balance. We had some great tutorials, but we kept hearing from teachers, students aren't retaining the information, they aren't able to apply the skills. So I had this great idea. They'll go through the tutorial. At the end of every lesson, they'll complete an open-ended project that asks them to apply the skills that they just learned. It will be creative, it'll be great. So, an example of that, they were learning to program shapes. So we took the artwork of Alma Thomas as inspiration, and we asked them to look at her artwork and create something in that style using Python. I was excited. This had everything. It was open-ended problem solving. It was creative and artistic. It went into expressionist art. It was bringing forward the work of a Black woman artist. I was so excited. It had everything. But I started going into classrooms and I realized no one was using it. They were skipping all of my open-ended projects. When I asked why, the teacher said, it's too hard, the kids don't know where to start, we can't do it. And I would always figure out a way that they could make it work. I would say, well, have you tried all our supports? There's code comments that you can use as a guide. There's a project planner that you should be using with your kids. I had all these supports and I could always figure out how they must be able to make it work. Well, 3 years later, I was coaching a teacher in a classroom who happened to be using this curriculum, and they were skipping the open-ended projects. With some distance, I was able to see that I had missed an opportunity to make my resource work. Because it didn't work in the classroom, it didn't matter that I could make it work. It mattered that the teachers could make it work. Because they couldn't make it work, no students were using these amazing projects. I still think they're great, but I missed the opportunity to have them actually be used. So that brings me to one of my biggest mantras that teachers I work with will constantly hear me say. If it doesn't work in the classroom, it doesn't work. End of story. So we have all these great ideas and great interventions for computer science teachers, but if they can't make it work, it sits there and it doesn't get used. So how can we make our open education resources work instead of sitting on a metaphorical shelf? Well, before we get into that, you might be asking, why am I talking about classrooms? Maybe when you think of these resources, you're like, well, they're used after school. They're used at home for free learning for kids who are really interested. They're used in nonprofits. Those are all great uses, and that's very valid. I want to challenge everyone here, no matter what area that you work in, to think about, in addition to that, starting to contribute to classroom resources. And here's the reason. There is a movement called CS for All. This is a movement to include all public school students in computer science education. Think of this, you might ask why. Think of this like science. We teach every kid basic science. And then when they get to high school, they have to take a certain number of credits, and then if they want to go into a STEM career, they can take more advanced courses or more specialized courses. But we want every student to have a basic understanding of what is the scientific method? How do I evaluate things in the real world using science? That's important to them functioning as an adult, and this is the same philosophy, that we want them to be computationally literate. So the gold standard for this is a required class during the regular school day. That's not happening everywhere, and that's okay, but that's where a lot of places are moving towards. So it's also widening our circle of who takes computer science courses and who programs. This includes lots of groups who have been underrepresented in the past in programming. And that also, just to point out, includes students with disabilities. So as we're programming, as we're writing materials, we want to think about students who are from different cultural backgrounds than us, students who learn in a variety of ways. There are many things to consider. And then additionally, I want you to know that this isn't a singular movement. It's being adopted in different areas, in different ways, and it's slowly all growing, but different states and cities may define this differently. So now that you have a background for that, I hope that I've inspired you to think about the classroom as we move forward. I also want to give us a background of open education resources versus open source software, because I think that many people in this room may have worked in open source software before, but not necessarily open education resources, possibly vice versa. So they're similar in that both resources are meant to be shared widely, used, remixed, repackaged, and free to everyone. For both, contributors are very passionate about what they do. And also, in both of them, there can be a problem with borrowing liberally without attribution from others, though not always. So there are commonalities. Some of the differences are open source software really focuses on, and again, this is very general. This may not be true of every project, but to be very general, on collaboration. Programs are living projects, so they're taking contributions from others. Their projects are changing. So that's one thing that's happening there. In open ed resources, often you're creating a lesson, you're creating a project, you create it, post it, it's done. And a lot of times that's a single person working on it. It might be a teacher who's sharing what they did. But it's not an ongoing collaboration in the same way open source software has been. And so what I would like to do is think about taking the principles from each of these and how can we bring them together and work together as technologists and educators to take the best of both worlds. So to dig into that, we're going to use a case study from a program I started last year called Raspberry Pi in a Box. This was through the K-12 Education Initiative at Cornell Tech. They had a mandate for us to innovate and make computer science education work in schools. And so this was part of that. So the problem we wanted to address is that everywhere, but specifically in New York City, middle school students, especially middle school students in Title I public schools, did not have the same access to physical computing, like Raspberry Pi, Arduino, all sorts of digital making, that students in private schools and better funded schools had the opportunity to do. And so we were like, why? Why does that happen? Well, the teachers aren't trained. It's a big time commitment for this type of training. The cost is prohibitive because it's not just somebody can donate Chromebooks, it's all the little pieces, all the parts. It's very complicated to manage in the classroom. But we see that middle schoolers really need something tangible in their computer science classes. And it also addresses some of the topics that are missing in curriculum, such as networks and computing systems. Another thing that we notice is middle schoolers were learning to program in the browser. And this was building up some misconceptions for them. So they would log in just like they log into an online game. And they would make something happen, just like they could do in some other type of game or activity. And so they weren't really understanding, how does software work with hardware? What is coding really doing? What's it good for in the real world? I can make a cat move, but what does that mean? So we wanted to make this tangible and help students see computing systems in action. Our solution was a one-to-one Raspberry Pi program. What that means is we envisioned incoming sixth graders receiving their own Raspberry Pi. These Raspberry Pis would live at the school, but by the end of their middle school years, when they graduated 8th grade, they would take home with them a working computer full of a portfolio of their computer science work. In addition to that, so it also addressed students who didn't have access to computers and portfolios for getting into high school, etc. Our goal was to keep the cost as low as possible, low enough that a teacher could go onto Donors Choose and raise enough money. We wanted everything ready to go. Here's how you set up. Here's what you buy. Here's the curriculum that you can choose from. We wanted to start to move kids out of Scratch by 8th grade, start to move them into Python. And we wanted subject area integration so they had time during the school day to do the work. So this is our big idea. Well, what did we learn from this idea? This is the first thing we learned. This is a slide from the official Raspberry Pi Foundation teacher training called PyCademy. So this is really part of Raspberry Pi's ethos, is that first attempted learning or failure is common and desirable. It's part of the learning process. And as experienced educators, we thought, that shouldn't be part of our process. But if you're dealing with a Raspberry Pi, if you're dealing with people, students, and classrooms, this will be part of the experience, and that's a good thing, just like it is if you're a student using the Raspberry Pi. So what bumps did we encounter? The first was in curriculum. I want to thank Chantel Mason. You can tweet her. She is the one who developed all of our open source curriculum. So she learned some things. Teachers weren't able to take what they saw on the internet. There's all these projects for Raspberry Pi, right? There's endless education resources. Teachers weren't able to take that and then make it into something that they knew what to do with in the classroom. They were unable to do that because they needed a format that fit into their schema for like what education is. So we formatted our lessons to look similar to what they might see if they planned a unit or a lesson plan. It's a little bit different because it needs to be flexible for everybody, but we wanted to cue some of the things that they would recognize so that they knew what to do with the information. Next, we did not reinvent the wheel. We relied heavily on Raspberry Pi's open education resources, and we used that as the foundation, and then we built on top of that. And finally, Chantel really dug into the standards. You know, a lot of us want to approach it as, oh, here's what I wish I would have learned. Here's something really interesting. But Chantel started with, what do the teachers need to teach? And can I understand where the kids are actually at? And she was able to really dig in, and because of that, she created subject-integrated lesson plans. So for example, in science class, they study urban farms, and they make an urban farm and monitor it with a Raspberry Pi. In English language arts, they are studying propaganda, and so they read a book, and they create a series of podcasts that are presented in a Raspberry Pi radio project. And this is part of their assessment for their ELA class. So that was pretty easy to overcome. Once we recognized the problems, we could address them, and we're able to come up with good curriculum solutions. On the other hand, peripherals and networking. I would say that there are perhaps no great choices in this area. We still have not solved this problem. This one's ongoing. The first thing that I learned is to be really clear about your program goals and base the choices for this on those goals. So for us, we chose, we did not want to use laptops and SSHN because we wanted kids to have the tangible hardware software experience. We want them using the Pi and seeing the Pi. We ended up using PyTops, which kind of obscured our goal of using and seeing the Pi. On the other hand, it solved some of the school's problems, which were, where are we going to put 30 more monitors in our school? So there are several options. We haven't found something that works for both the school and the students yet. We're working on it. And we also learned, no, it's not just us. Every time we hit a bump in the road, we thought, oh, we just can't use the Raspberry Pi that well. We must not know exactly what we're doing. But what we actually found out was that with certain products, there were user design issues that were causing these problems on a wider scale. And it was important for those companies that we went to them and told them what was happening in the classroom, because to go back, if it doesn't work in the classroom, it doesn't work. This doesn't apply to most open education resource projects, but I just want to touch on it because there are some programs that are open. Scheduling and budget are big obstacles in schools. If you are creating some kind of open education resource, just because what you created is free does not mean it's free to implement in the school. So thinking about what are the costs, a lot of times there are cost trade-offs. Schools can work harder to have something for free or pay less money, but they may need more in-house expertise than they have. So again, you might have a solution that works for you, but it's not going to work within the school day for the teachers who are there. So just something to think about. Oh, and we also found it was great for teachers, more than one teacher to do this, to have a cohort that's in it together at the school. Lastly, we found teacher training is important. Nobody was going to use our curriculum unless we could figure out some type of training. Because we want this to be a program that's accessible and ready to go, we're looking at what is the least amount of training? What is the most accessible way for them to get the training? We cannot send every middle school teacher in New York City to PyCon. So how can we give them enough training to implement this program so that their students can have the physical computing experiences? We're looking at lots of different options. Can we get it down to a one-day thing that's offered throughout the boroughs? Can we do it online? Can we use some of Raspberry Pi's online resources? So this is an area we are also still exploring. We've also realized teachers need to do the projects. They need to play and they need to master the materials. Many computer science educators are new. They're new to computer science, even at the high school level, and they are learning along with their students. So in our trainings, we really focus on them building confidence and building their skills. So moving forward, we did learn that students can do this despite all the bumps and obstacles, and teachers, without the official training, can do this. We have subject area middle school teachers who've never touched code before, having their kids use Raspberry Pi with Python to build these projects. So they can do it and they enjoy it. And that told us that it's worth dealing with all those failures that come up. It's worth dealing with the bumps because the kids get an experience that they would not get with an online tutorial, which for them was the alternative. And iteration is really key. You just have to keep trying and keep addressing problems as they come up. So I want to break this apart and abstract it out a little bit and think about some principles that we can apply to every open source education project. So the first concept is that content matters, but not at the expense of logistics. What does that mean? I'm not saying, like, forget about the content, it doesn't matter. I'm saying if you have the greatest content in the world, if schools can't figure out how to implement it, students won't get to use it. Oop. Next, you should never assume that your user looks like you or thinks like you. Refuse the temptation to design for your younger self. Access counts. It is so easy as an educator for me to think about myself when I was in 7th grade. How did I learn? What would have been fun for me? That does not work. Every educator learns pretty quickly. It's very tempting. So user-centered design, thinking about your audience and what will work for them. And most of them are learning programming in a sort of non-traditional environment, the traditional way of learning Python, which is what I did. I went online by myself. I worked through Learn Python the hard way, and I was off and running. That's not going to work for our students in classrooms of 30 people each with no background. Access counts. That means two things. That means access to the curriculum for students with disabilities, but it also means to think about what access they have to technology. Don't assume every student has a computer. How else can they program? It's not ideal, but there are apps for programming Python on your phone, on a tablet, in the browser. There's all sorts of options, so think about alternatives and don't assume that kids have access to these tools. Just accept that you're a UX designer. I'm sorry, but you have to be. If you have a blank white page full of text filling the page, that's not going to work. A teacher's not going to know what to do with that or how to pick it apart. So if you want your projects to be used, you want to think about design. And then testing in an education environment is better than having a kid related to you test it. If your fourth grader can do it, doesn't matter. Can a fourth grade class do it? Why don't you go try? Go see. And we could talk about different ways how you can build relationships with schools to do this testing. If there are too many Python in-jokes, it's probably a bad idea because they exclude new users. If you think it's too obvious to explain, but explain it anyway, it's probably a good idea because it wasn't obvious. And your contributors need guidance, especially in these areas. So I love Python in-jokes, but my students don't. They really don't get Monty Python. I wish they did. And they really don't care once I explain it to them. So when students and teachers read that, they feel like outsiders because that's another thing other than the content that they need to decode and figure out. So we want to be welcoming with the materials. Also, if you think it's obvious, if you think you went all the way back to the very beginning, stop and go 3 steps before that, because they don't know. And a lot of teachers, even high school computer science teachers, have never used Git. And you've got a project up on Git that is amazing, and they don't know how to use it. So these are just some things to think about to make sure that your projects work. And letting your contributors know, giving them some guidance so that you're not alone in making it work. And again, if it doesn't work for the intended user, it doesn't work. You will fail, and it will still be worth it. This work is so important. We have a huge need right now in computer science education for projects, for collaboration between educators and people in technology. There's a lot of curriculum out there, but it's not all great. And your contribution can make a huge difference. So even if you make some of these mistakes, it is still worth it. Finally, resources that exist are better than resources that don't. So please, if you have an idea, do it, even if it's not perfect. Resources that can be found are better than resources that can't. If you have an idea and you do it, how will you get it out to teachers? How will they find you? Resources that can be found and used by your target user are even better. So let's do more of that. So I present to you the Zen of Python Open Education Resources. All right. Sorry. There you go. Write it down quickly. I'll also go back. I could go back to it during the Q&A. Okay. So what are 4 takeaways that you can use today during your sprints? First, think about how you can create templates or guidelines for your contributors. How can you educate them in this area so that you can bring in the widest amount of contributors and they can contribute in a meaningful way? How can you give them guidance? One idea I have for my project is to use GitHub Pages to create a template and let contributors know that they should use the template to submit their projects for our open source project. Next, bring on educator advisors. Or if you're primarily a group of educators, bring on advisors who are Python developers, who are in the industry. If you're primarily in technology, bring on educators. Let's work together. Next, let's start turning these educational materials into living documents. They are anyway. Teachers virtually cannot take something off the internet and then just turn it around and use it at face value in class. They're already having to make changes. So let's make that part of our culture. Let's start, taking pull requests. Let's start making things live and taking contributions. And then next, whenever you can, test in a classroom. So if you can plan for that during your sprint, that's great. So that is it. Thank you for listening today. Please contact me and keep the conversation going. I did write a book this year. If you're interested, it's there. If you're not, no big deal. I would love to take questions. I'm just going to flip back here since everyone wanted that one. Yeah. Yes. Oh God, I feel you. Awesome. Yeah. Sure. So actually, it's much easier to use Scratch because Scratch is available in so many different languages. There's a drop down of like 40 languages. You can pick and it switches the blocks to that language. Python doesn't have that. We don't even have documentation in a lot of languages, let alone documentation for a middle school student. So a lot of times we are differentiating with Scratch. Another thing is we use an approach called translanguaging, and also pairing that with something called literate programming. So an example of literate programming is where a student might describe what they want to do and they might ask a question like, how can I tell a story about, X with Python? And then they might start writing it. They might start writing how they're doing it. Then they gradually start writing it in what they think is pseudocode, or in pseudocode in using commands that they think might be in Python. It's okay if the command doesn't actually exist. Then we take that and we look at those commands even if they don't exist, and we talk about that, and we talk about what could that be in Python. There's some great people, Chris Hoadley and Sarah Vogel at CUNY and Columbia, who are doing research on teaching computer science to students, to English language learners. And they're doing this research and have shared it with us, and so that's my source on that. And I'd also love to learn from you since you've been doing it with kids in the field. I will. Yes.
How do you approach this, and what would be good resources to start with? I found that a lot of them online resources, like the simple stuff, just with the quick.
Yeah, that's a great question. It is hard. There's lots of solutions online. There's not a lot of research to show us what actually works. But there are a lot of attempts at solutions. So one of those is the company that I used to work for, Codesters, that lets you drag a block over. It turns the block into Python once you drop it in, and then it asks the students to modify the Python. That uses an approach that's called Use, Remix, Create, that is research-based in computer science education. But we don't know that that actually works for transitioning students. Trinket has the Python blocks and then Python. We don't know if it works. It's worth a try. But also I just think finding something that's motivating and interesting for the students, and especially because he's not in a classroom, he's working with you, something that's personally motivating, a project he wants to do to start figuring out Python.
I definitely found that in hardware execution. Once we, with my son, I showed him
Yeah. I thought it was just middle school students and elementary that the hardware made a difference for microbits and Raspberry Pi, but I actually, when I go to SIGSE, the Special Interest Group on Education of the ACM every year, I hear graduate professors talking about how crazy their students went for Raspberry Pis because there was something magical about holding it and touching it, and it improved their pass rates. So it's not just young kids, it's everybody. I have found that school librarians are often on the forefront of this type of work, and not just computer science, but especially digital making. I mean, just librarians have a history of leading the maker movement in this country, so I don't see why they shouldn't be leading it in schools. Also, oftentimes administrators feel that that's a good place for their digital resources to fit in. The librarian's already managing a bunch of digital subscriptions and things like that, so we have school librarians also managing all the robots and being the expert on the different robots, and having students come in, and then the library becomes the place where they can come to figure things out, and to get kind of extra help outside of their computer science class. I don't know if that answers your question, but great. Yeah. Great. Yes. Mhm. Mhm. Absolutely, you hit the nail on the head. That is a tension that will always exist, and it is so true what you said. Um, so first, I just want to point out that by starting to incorporate computer science education during the school day at every grade level, we are already part of one of the most massive systemic changes in public school education in the last century. So that's a big deal, and that's a huge amount of change for our public school system, because as you were saying, change is not easy, and the culture is not set up for innovation and learning through failure and building and making and experimenting. So that said, there's a couple different approaches that I take. One, as a coach, I try to create that space. I let administrators know this is not a tested area. So this won't be part of the evaluation of the teacher. The other thing is that we find that as we train computer science teachers to have this mindset, it is starting to become contagious in the rest of the school. So I'll see a 9th grade classroom that it's a computer science classroom, and the other teachers in the school all know that that's where the kids go to learn how to use resources, how to problem solve independently. And they've sort of discovered that that teacher is helping them with all of their work because of the open problem solving that's happening that wouldn't normally happen in the other rooms. In a kindergarten class I was in last year, the teacher said to me, "This is the only place the students get to practice cutting." They didn't know how to use scissors. They don't get to practice. And I said, if that's Well, that's a great use of computer science time. Let's keep doing that. So I think individual teachers are making change, as they're creating this environment within their classrooms, and to some degree, because it's still not tested, we have some protection for that. We'll see what happens in the future. Yeah. Mm-hmm. Pair programming does. There's a lot of research to back that up. Pair programming does improve performance and improve participation from girls specifically. Flipped classrooms, the jury's out. That can create an access issue. It works often in maybe a middle class school environment. It doesn't work all the time for everybody. So it just depends on the learners. But I would say the jury's kind of out on that. Thinking about children where they are developmentally is very important. I kind of rearrange the way that I teach Python to them. I think about math. In math, we do concrete, representational, abstract. And I use the same principles for Python. How could we start with objects? Both objects as a programming construct and literal manipulative objects, and how do we move and build from there? So with Python, we often actually start with something a little more advanced, an object, sometimes a sprite if we're using Pygame, or something similar, and then go from there rather than just starting with numbers, strings, etc. I personally don't. At Cornell Tech, I work with some graduate students who are trying to, and it's been really difficult. It's difficult to teach to teachers, and it's more difficult to teach to students. It's a great problem for us to work on and solve together. Yeah.
Earlier you said that you would speak to some of these ways to partner with local schools.
Mm-hmm.
And how you actually initiate that conversation, that dialogue with them.
Yeah. So in many places, there is a university that's facilitating computer science work in K-12. So that's a good place to start, trying to find who are the people in my area that are maybe researching CS education. There's often somebody in a CS ed department or an education department who's doing that. And they're often looking for practitioners, people who want to be part of that and do related work. So that's one way. I don't think there's an easy answer to this because, again, it's a big unsolved problem. I actually met somebody at PyGotham years ago. He said, I'm really excited. I want to do this. And I said, okay, just, get to know a teacher and go do it. A year later, he was like, I've been working in a classroom for a year with a teacher just as a volunteer on his own. I think that's really rare. There are programs, volunteer programs like TEALS, which is a national program where software engineers can volunteer in the classroom and work directly with teachers. And I think that's a good place to start. And then you build the relationship with the teacher. Maybe they want to continue work together and contribute something. Maybe you could do a small project just by, if you have a child approaching their teacher. Hey, can we try this in your classroom? So there's different options. I don't think there's a ready solution yet. But if you have initiative and you want to start building those bridges, it's a great idea. One more thing, it could be going to technology educator meetups in your area and asking who's interested. Yeah. Ah, yes. She just said public libraries have a good in with many public school systems. Thank you. Yes. Hmm. Okay. Yes. Hmm. So specifically for students who are blind or low vision, there is a learning language called Quorum that is made specifically for those students. Um, Also, I would direct you for students um, who are deaf. Deaf Kids Code is an organization that focuses on that. Access Computing out of the University of Washington focuses on accessibility and CS education, but primarily students who are blind or low vision or have a physical disability. My area of study is students with invisible disabilities, so that might include a learning disability, autism spectrum disorder, ADHD, emotion and behavior disorders, which do affect learning. So everything in that realm. And we've found, so if you're familiar with Seymour Papert and the history of computer science education, it's based on the idea of constructivism and what he also calls constructionism, which is building to learn. But we've found for those students, they need help accessing constructionist activities. So we have a philosophy of supported constructivism. So what that means is we scaffold the process for students. We focus on all of their executive functioning skills. We help them set goals. We help them plan. We help them, how do you break down a project? How do you plan a project? How do you figure out steps? All of those things we scaffold to start to teach them how to do this so that they can have access to these more open-ended projects. We want to start with direct instruction, but we don't want to leave them at direct instruction because then they wouldn't be able to access the richer learning experiences, though they need that direct instruction to start. Yes.
I would just like to make a quick comment about accessibility, because I've heard people saying that Python cannot be used for people who have vision impairment because of the significant white space. However, that's a myth. And if you want details, I don't have the details with me, but I work with people that are blind and that code in Python, and there's ways of configuring the screen reader so that it reads the indentation.
Excellent. If you couldn't hear, he was saying there are ways to configure the screen reader to read indentation in Python for programmers who are low vision or blind. Thank you. Anyone else? Yes.
So I'm a high school senior, and I work a lot with elementary schools in my area teaching programming workshops.
Cool.
One of the big problems I run into is a lot of them have like Chromebooks.
Yep.
That you can download stuff. There's
Yep.
ad blockers. There's website blockers.
Mhm.
How do you deal with that if you're running a fully browser?
So this was part of the problem we were trying to address with the Raspberry Pi in a Box program, because we were running into these problems with just doing things in the browser, and we wanted to move them out of that. We couldn't afford to buy laptops for the school, so we said, okay, let's try with Raspberry Pis. So that's one way. There are different options. I mean, I think just using the best tools in the browser that you can is probably the most realistic, unless you can influence school budgets, etc. A lot of times, though, if you are in a position to advise administrators on their tech purchases, we have been advising them to purchase laptops instead of Chromebooks. They don't understand why, so they really need education on why that's important and an explanation of how it will benefit their students.
So this is a very interesting question because I work for Google,
Yeah.
and we are we are working a lot with schools to give them Chromebooks and promoting actually in-browser teaching, right? And I know the limitations with Chromebooks. So so how do you? So what is your suggestion to Google or an industry or tech partner who's working with the schools? What can I take back?
Do you mean in the context of giving Chromebooks?
Yeah.
I would say, so for when I think about Google, I think about Google CS First, which we use with students. So thinking about applying some of these things to CS First and the open education resources that Google puts out there. So for example, I know they've done a lot of testing in schools, and it solves some problems. For example, it's not like the tutorials where the students just do the thing they're told and then they're not able to really retain it. They have to take in some information and then apply it to their project. But then they also get lost. They don't know where they are or what to do next. They need education for like how to use the interface. So I would say just talking with teachers and having the engineers themselves go into the classroom is a great start. Not just somebody on the customer service side, but the engineers who are making decisions about the product. And then just also to talk to somebody, to bring in an expert to talk about accessibility as well. Yeah.
Yeah, why I find this so interesting is because in the last few years, there was a huge shift to go to in-browser teaching, like with Jupyter Notebooks and other things. And now we are talking about having more tangible education resources.
Yeah, well, part of the reason is if we look at the K-12 CS framework, we have a lot of curriculum related to the strand about programs and programming and algorithms. We don't have a lot of curriculum related to the strands about computing systems and networks and the internet. And the people who are sort of running the CS framework, they are actually looking for curriculum. When they talk about alignment, they don't mean, oh, you're aligned to this one area. They mean you hit on everything in our framework. So that's a huge need that needs to be filled, and I think that's part of it. Hi. Thank you.
Have you seen any, but two questions. One is the in-browser related instruction. I have something to give to you.
Thank
But,
you.
because I don't have time to do anything, but I basically, this past summer, I had colleagues taught a 2-hour workshop to Spanish-speaking students that had minimal access prior to computers, where they could not install anything on the computer. So it was an interesting challenge.
Yes.
It was a combination of teaching them interactivity and using P5.js
Oh, yes. Awesome.
and the very alpha version of the Zen translation already into Spanish. But have you seen any tools that help guide people through checking that they've met the standards?
I have not. That's a great idea. That's actually part of, so today during the sprint, the mini sprints, part of my sprint is about doing some of these things, building some of these templates, and one of the projects is starting the framework for a database that will eventually become a guide for non-educators to be able to look up standards and understand them. I think that's a ways off. I definitely haven't seen it for non-educators. And where the places that do have this kind of thing definitely don't have computer science standards as part of their database. So. Yeah. Exactly. And so as somebody in technology, I feel like a big problem is it's not just finding the local CS standards that apply to you, because it's different for every state. And it can be different for different classes and grade levels where you go to even look to find these sets of standards, right? Are they getting a CSE? Is it an AP course? Is it, in a state that has adopted CS standards? In addition to that, like you're saying, they don't have time during the school days, so many of them will want to do it as part of another subject area, and then you need to find and interpret those standards for that subject area. So it would be amazing to see a project that helps people in technology to not just find the applicable standards for their projects, but that sort of interprets it for them, that helps them to understand how that fits into their project. So if anyone wants to brainstorm about that, please join our mini sprints. Yeah. Oh, awesome question. He asked about what role do I see for para-educators. There are different terms in different states. Will you just clarify what you mean? Do you mean a para who's a teaching assistant, or a para-educator who's like running an informal learning program out of school? Okay. I see. Okay, so it's not, in New York, a para-educator is somebody who assists specifically with students with disabilities in the classroom. That's not what you mean, right?
Well, yes, to a certain extent.
Yeah.
The instance that I'm thinking about applies a little more.
Okay, awesome. But in the classroom? Yeah, so this is something, specifically to para-educators who might help students with disabilities. I've done research with Maya Israel related to this. She has a guide up, which I'll have to share. I don't know where it is exactly. She has a guide up online in her lab about how to help para-educators to teach CS, and how to train them, and how teachers can work with them to be more effective. And I think a lot of the same principles would apply. So it's about training them, even if the teacher has to be sort of modeling and training them on the fly. Teaching them, emphasizing least to most interventions, so meaning not having them jump in and do for the student. Not just para-educators, but teachers also have a tendency to, they need something fixed, I'm just gonna jump in here and start typing. We tell students not to touch each other's keyboards or mice or materials, and we tell teachers not to touch students' keyboards or materials, and the same would be for para-educators. So I think really emphasizing how they don't need to be fully trained to be able to walk a student through problem solving, and to not try to solve the problem for them, which is a natural instinct the guy. Oh, thank you. Thank you for finding it. I appreciate it. Awesome. All right. Thank you so much.